the functions and the inverses, where of the exponential one comes there most often, and then also the log one, because those are the two ones that they actually test a lot, not only, but a lot. So this one was given the exponential, and they're asking me for the inverse. Find the equation of, and then they just say, so they can say the inverse g to the minus 1 or just g to the minus 1. First mark that you're going to get is for saying x is equal to 3 to the y. For the swapping of y equal to the x into x and y swapped. Then we write it in the form y equal to
log 3
base of 3
x.
And if you're nice and cute, you write there x is bigger than 0. That's it, 2 marks. Then the second question was a translation one again. They're telling me there's a point, and that point is on another thing that is h, and h looks something similar to that because there has been a translation. If you look at h, and they're asking me, h is a translation to g. What will p then be on g? What will p then be on g? So this is p on h. So any point will have the translation that's happening here. So to get from here to there, what happened with x? You said
4 units to the right.
it went 4 units to the right. So to the point went 4 units to the right, and that would be 10 there. So this means you went from there 4 units to the right. That's why you said, sorry, you said plus 4, and plus 4 means, okay, minus with 4, are you with me? So going from there into there, how would I get that answer? Is this right?
Yes.
Okay, so I've got to take the y value, and that's the easy one. But remember, from here, it went back to there. So what happened from here to there?
Move 2
You
down.
moved 2 down. You said minus with 2 to get to there. So you've got a minus with 2 to get to 9. Are you happy with that? All right. That was it. 4 little marks for inverses in that specific question. In the next question paper, they're giving me the sketch. They're giving me the asymptote that goes through negative 16, and they're giving me a point, and then they say find the equation. Remember, from grade 11, there's actually a lot of stuff that can happen in general with a basic general equation of exponential graphs. There's a b and a and a p and a q, but like you were taught in grade 11, we won't ask you 4 variables. So in this one, what was the variables? P and q. So the a part was there, and the b part also was 1. Are you with me? So there's only 2 of them available. So I'll never just give you the sketch and say find the equation. They've got to give you the indication of what you're looking for, with some, either the A or the B or the P or something that's been given to you. So what's the first thing that you know?
We know what Q is.
That Q is negative 16. They asked me for that, so we say Q is equal to negative 16. So far I know that Y is equal to 2 to the X plus P, negative 16. And to find how many variables now?
1.
Just 1. I do that by
Substitute.
and that's why I needed the 1 point. I couldn't have done it if I didn't have a point, and the point that I do have is
3 and 16.
3 and 16. Okay, kind of like basic stuff. So in the place of y there's a 16, in the place of x there's a 3. Right, and then what do we do? 16 over? This is like grade 11, right? It's an exponential graph, and the bases, they're going to be the same. That's the ones that we were used to up to now. If they had been 31, we would have gone for logs. But if the bases can be the same, we're back. Can we go for logs? Yes, you can. Logs is now an additional tool that you're allowed to use, even if it's not necessary. So we've got 2 to the 5, 2 to the 3 plus p, and then 5 is equal to 3 plus p because we're making a logical deduction, and p is equal to 2, and I'm done. They never asked me for the equation, and it's not necessary to write it. If the sum had gone on asking the domain, range, what, everything else, you would have said, in other words, fx would have been 2 to the x plus 2, and then minus with 60. But that was not necessary for this sum, because they asked me for p and for q, and then they both are. This would have most probably been worth more marks, but maybe they gave you 2 for knowing the q as well. So 4 marks. Sketching a hyperbola. If I have to spot anything in a question paper, this is it. It's going to be there. This was worth 6 marks. Usually it's worth about 7 marks. And there can be much more questions after sketching it than just domain. Axis of symmetry, etc. And I'm going to add that here as well. Just extra stuff. So it can easily be like almost 10 marks for a hyperbola knowledge. Let's have a look. If you have to go sketch it, where do we start? And what do we write? We always write the asymptote equations, namely y equals 1
And x equals
and x
negative
equals negative 2. Girls, boys, right? And then can I start sketching? Yes. Because that's worth marks. Knowing that y is equal to 1. So that's at 1. And that x is equal to negative 2. Negative 2. So that point over there is the point. Negative 2 and 1. Do you need to show that? No, why am I doing that? Because I'm going to get to the axis of symmetry just now, and that's what you need for it. But you don't have to sketch that. So, tell me now, is it a quadrant 1-3 hyperbola or quadrant 2-4 hyperbola? 1-3, because it's positive. So that's why it has to be here somewhere. Now I'm just sketching it. What's wrong with me? And it has to be here somewhere. Because now I know, man's going to ask me, what's that? And what's that? Because I need the x and y into this. But if you did this for a test, because you had 2 minutes to do this, have you got marks? For sure. But you're going to lose the marks for not working out the x and the y intercepts. Alright, so for the x and y intercepts, you say x equal to 0 for the y intercept. So we've got, like always, please don't forget, the moment that you want to put x equal to 0, y equal to 0, you're busy with the intercepts, with the axes. So this one will be 1.5 plus 1 gives me 5 over 2, which is 2.5. So that gives me 2.5 over there. Say my answer for some mystical reason was a half. Somewhere I went wrong with my calculation. And I got to x, the y-intercept is a half. Something should have told me. I don't know what I did wrong, but something's wrong. Because it can't be there. It's got to be more than 1. And if I work out the x-intercept, it's got to be less than negative 2. Are you with me just with the logic? There's nothing wrong with the sum. If something like that happens, you calculate it incorrectly. So for the x-intercept, we put y equal to 0. And we've got lots and lots of alternative techniques to solve for x. Help me. Negative 1 to the one side. And then cross multiply. So this is going to go to the top. Oh, and I wanted to take this to the bottom just because I can. What did I do? I swapped them. All cross multiplication would have made that minus x and minus 2. I want to make the point that it doesn't matter the technique, your answer should be the same as mine. So then this answer would be, so that x is equal to any technique that you wanted to use, LCD, whatever, you get to x is equal to negative 5. Alternative techniques. Remember the marks go for, you put y equal to 0, and then the mark will go for x is 5. Because it's a linear equation. All the techniques that you wanted to use, it's up to you. Right, so this is negative 5. I'm happy about that. It pans out on the sketch. And this was f that I was sketching. The only other question that they asked me was, what is the domain? So the domain is?
X is the derivative of real numbers. X cannot equal negative 2.
It cannot equal, it's just less than negative 2. And if you just wrote x is negative, less than negative 2, you're actually right, because we are busy with what's wrong. So there's the x that's negative 2. Oh, you are right. I am wrong. I'm only looking at this thing. I was thinking about something completely different now. That's wrong. Because now I'm just saying that it's this. What about the rest? So if I wanted to correct myself, let me make it as if it was purposefully. And I could say, okay, now you know I made a mistake, but I covered my tracks. But we never write that. We just say, x is not equal to negative 2. I was thinking about something completely different now. Alright, so the same with the range, if they ask me, but let's add our own question here. What are the axes of symmetry? Let's make it particular. The axis of symmetry, that is an increasing function. Ooh, there's a lot of mathematical terms there. So I need the axis of symmetry. For a hyperbola, what is the axis of symmetry? What are the axes of symmetry? Y equal to plus x plus c, or y equal to minus x plus c. But now I'm asking for one specific one because I don't want to give so many marks for the question. I'm asking for which one of the two? The positive one. Because I'm saying that this axis of symmetry must be an increasing function. So if I look at the graph, that straight line that's got to go through there, this is the positive one, which I can call a positive gradient, increasing, ascending. This one, negative gradient, decreasing, descending. Are you with me? All those terminologies. So I'm not going to do this one. They asked before this one. So if I do, and then I only have to solve for C, and that's where I substitute one and only point ever. And that's that point. Name it minus 2 and 1. If you wanted to go sketch it, it would mean that this is the graph. Like that. Y is equal to x, and I'm trying to find out what my C value must be. The negative 1 would have gone like that. Still mirror imaging there. Here it's mirror imaging like that, and like that, the mirror images. So if I substitute that point negative 2 and 1, it's going to be 1 equals negative 2 plus C, and C is equal to 3. So that has to be a 3. Done. Please don't throw away easy marks. Everything is done, but you haven't written the equation. So the equation is y equal to x. Oopsie, I missed the y. Don't forget to answer the question. That is the axis of symmetry with a positive gradient or an increasing function. You need to add it to make something more about it. It doesn't make any sense to ask you for maximums and minimums in a hyperbola or turning points in a hyperbola. I could have asked you, is f an increasing or a decreasing function? Is f an increasing or a decreasing function?
It's
Decreasing. From left to right? Decreases. When I make the jump? Decreasing. Are you with me? It's a decreasing phase.